So in 17, we want to convert e to the fifth equals 148.4132 to a logarithmic equation. Now, we know this. Logarithms are exponents. All right, so I'm going to write this. I'm going to write the logarithm, leave a space, is the exponent. Well, the exponent here is 5, right? The exponent is 5. Now, the base is e. All right, so there's an e. So I'm going to write this, and I'm going to change it in a minute. E, and the only other number here is, I'll put it in parentheses so it doesn't get lost, 148.4132. But instead of writing the log base e, I'm going to write this as the natural log, right? The natural log is the log base e of 148.4132. That's equal to 5, and there is my logarithmic equation. I've gone from an exponential form to a logarithmic form. I want to convert r to the a equals 144 to a logarithmic equation. I've got the exponential form. Convert to logarithms. Well, I do everything by knowing this. Logarithms are exponents. So I'm going to write the logarithm is the exponent. I'll leave a little space here and fill it in a minute. The logarithm is the exponent. Well, the exponent is the a, right? There's the exponent. So the logarithm is the exponent. Now, the base here is r, right? The base to this power here is r. So I'll put r down in the base. The only other number is at 144. So there we go. Logarithm base r of 144 is equal to a. Now here in number 19, we want to convert this logarithmic equation to an exponential equation. And we're going to do it by remembering that, what am I writing here? That logarithms are exponents. So read what you have and then translate it. We have the logarithm is 2. Now the logarithms are exponents. So I'm going to read this as the exponent is 2, right? Logarithms are exponents. So read it like this. Logarithm is the exponent, but logarithms are exponents. So exponent is 2. So the exponent is 2, and exponents go on bases, which also happens to be a 2. So there's the base. Now that base is this 2 right here. Here's the exponent, 2, which happens to be that 2 right there. And this is equal to 4. All right, so I said the logarithm is the exponent. So the logarithm exponent. So the exponent is 2. Exponents go on bases, and the other number is 4. And it's a true statement, right? 2 squared is 4. Now let's translate this logarithmic equation into an exponential equation. Keep in mind, logarithms are exponents. So logarithm is the exponent. So just change logarithm to exponents because logarithms are exponents. So the logarithm is -3, so I'm going to say the exponent is -3. So the exponent is -3. Now exponents go on bases. What's the base here? This is the log with no base, so the base is assumed to be a 10. So 10, that exponent, that must be the 0.001. And sure enough, 10 to the -3, all right, that's what we're looking for. 10 to the -3 is 1 over 10 cubed, which is 1 over 10 times 1, 10 to the 1, 10 squared, 10 3, which is tenths, hundredths, thousandths. It works. Now in 21, we're going to convert this logarithmic statement into an exponential equation. It happens to be a natural log, but that's good. Natural log of 30 is this number here. Logarithms are exponents. There's the exponent, and what exponents go on base. What's the base? Well, the base of the natural logarithm is e. So this is going to be e to the 3.4012 is equal to 30. Now this is all approximate because this really goes on forever. So this is a good approximation. Let's convert this logarithmic equation to an exponential equation. Now keep in mind, logarithms are exponents. So when I read this, I read it as the logarithm is negative y, but since logarithms are exponents, I can read this as the exponent is negative y. Well, exponent, so that's the exponent. Exponents go on bases, and the base here is n. So I'm going to write this as n to the negative y is equal to r. That is the corresponding exponential equation. Now we're supposed to use a calculator to find this, so I'm going to press log on my calculator. I get a parentheses, type in 97 and close that parentheses. And now it says to select the correct choice. Oh, all right. So I'm going to write this to 4 decimal places. So I'm going to write this as 1.98. Here's what my calculator shows. All right, so to 4 decimal places, 1, 2, 3, 4, I'm going to round that up to an 8. So I'm going to say that the log of the common logarithm of 97 is 1.9868. In 24, we're going to use the change of base formula to get this one here. The log base 110 of 0.3. All right, so I don't have a base 110 on my calculator. So I know the change of base formula. It goes like this. I write the new base here, and I want some number m. Right, the logarithm of some number to this new base, here's how I get it. It's a fraction. Now I'm going to write it like this so I can remember it. Log, here's the new base I want, or here's the base I have. I know a log base A. I can use E or 10, common log or natural log. All right, so this is the base we want. That's the base we want, or the new base. And this A, that's the base we know. We know 10 or E. All right, now, here's what numbers I put here. Now, see a way I've written this over here? I have kind of an upper and a lower. So the upper goes in the upper position, the lower goes in the lower position. So it's an M up here and a B down here. Now for us, we're going to have the log base 110 of 0.3 is equal to, all right, write it like this, log over log. Now, the new base is 110. What's the base that we know? Well, I already wrote log. That's going to be base 10. So base 10, and then upper number goes in the upper position. So 0.3 goes on the top in the numerator, and the lower number, the 110, that's the upper number, the lower number, that goes in the lower part. So that's going to be 110. Let's see if I can get it to right here. All right, so on my calculator, I'm going to type this. I'm going to press the log key and put in, all right, so I press the log key, I get a parentheses. Put in 0.3, close the parentheses. Press the division key. Now press the log key again, you get a parentheses, and put in the 110. Close the parentheses and press enter. Now when I did that, I got negative 0.256, and so on. I'm just going to round to 4 decimal places, so I'm going to write this as negative 0.2561. So I'm saying, I'll do it up at the top here. Here's what we're saying, that the log base 110 of 0.3 is negative 0.2561. Right, that's what we're saying. And what it means is this. Logarithms are exponents. So that's an exponent. And that's the base. So we're saying that this would be true. That if you take 110, raise it to this power, 0.2561, you should get really close to 0.3. And the last problem here in this section, number 25, says to find the logarithm of base 200 of 60. using common logarithms and the change of base formula. All right, change of base formula goes like this. The log base b of some number m is equal to this. Now, write log over log. Here's how I remember it. This b, that's the new base that we want. Okay, that's the base we're looking for. Now, in order to get that, I need to use a base I know. It says to use a common log, so that's why I typed log instead of ln. ln is the natural log. Log, common log, base 10, so that's base 10. Have that one on our calculator. And now, I have an upper number and a lower number. The upper number goes in the upper position. The lower number goes in the lower position. That's the change of base formula. So for us, we're going to have the log of 200 of 60 is equal to, all right, let's use a base we know, base 10, log base 10. Now the upper number is 60, the lower number is 200. So the upper number 60 is going to go in that upper position, the lower number 200 in the lower position. Let's just do this. So on your calculator, press the log key, you get a parentheses, so put in the 60, divide, press the log key, get a parentheses, put in 200, and then be sure to close those parentheses. And I got 0.7727, that's a 7, 76, dot. So I'm going to round this up. All right, 0.7728, and there we go. We're done.